Welcome to part 2 in the Java2Life tutorial series. In this episode, we'll be talking about primitive types and variables. A variable is a name associated with a memory location in the computer where you can store a value that can change or vary. So in other words, a variable is a name associated with a place in the computer where you can store a value, and that value is variable, meaning that it can be changed. In order to initialize, that's the word for creating a variable, you need two things. You need a type and a name. So the type defines what type of data you are going to be storing, and a name is basically used in your code to refer to that data. So what this looks like in code is you have, let's say, the type int, and I'll explain all of the types in just a second. And then you have a name like my number, right? And this is saying I'm creating a new variable, my number, and it's going to be storing data of type int. In order to give a variable a value, this is called declaring, you need two things, an assignment operator and a value, okay? So an assignment operator to our human eyes looks like an equal sign, and a value is basically whatever value you want to store here. So you have the name of the variable, which is just declared in this line, is assigned to this value using the equal sign, right? So in other words, this name correlates to this value, okay? Now, as you see here, there's a lot of different data types, okay? And these are called the primitive data types. They are the basic structure that make up Java data, okay? So I've split them up into categories and I'll explain them one at a time. So the integer is used for numbers which are humanly, like you can process them as a human. They go from about 0 to 4 million, and I'll use an example here to make this make sense to you, okay? An integer would be storing the amount of money you make in a year, okay? It's storing a humanly processable number that doesn't, have too many constraints on the small side. So, you know, you can write decently large numbers, but it's not so massive that it takes up a lot of space in the computer. But if you need larger numbers or smaller numbers, there's these two data types called the short and the long. So a short stores very, very small numbers, right? And I say very small on a computer level. These are numbers from 0 to 65,000 something, right? And you are going to be using this number. If you use an int to store the amount of money you make in a year, you'll be using short to store the amount of money you make in a month, for example. Okay? Now, a long is significantly larger. It's actually, so an int is the base, right? A long is 2 times as big as that, while a short is 1/2 the size of an integer, right? So a long can store absolutely massive numbers, and a short stores relatively small numbers, okay? So if your number, my number, is an integer, then it'll be storing the amount of money you make in a year, for example. If you have a short, that'll be storing the amount of money you make in a month. If you have a long, that'll be storing the amount of money you make in 100 years, for example, right? I mean, this is all an example here. But a long stores really big numbers, really, really big numbers. A short stores decently small numbers, and an integer stores reasonable numbers. The thing is, all three of these data types only store whole numbers, okay? If you want to go to decimal points, you need to use either the float or the double, okay? So a float literally just stores decimal points. It's defined in the exact same way you define any variable. You have the type float, you have the name of the variable, and then you assign it a value, and it's going to have a decimal point in it, right? The difference between a float and a double is that a float has a relatively small amount of decimal points that it can go to, right? Meaning it's less precise. Meanwhile, a double has more decimal places which it can go to, meaning it's more precise. Yet, the less precise it is, so if it's a float versus a double, right? A float will always take up less memory than a double does, meaning that you want to be conservative, okay? If you don't need a massive amount of precision, you're going to use a float. If you do need a massive amount of precision, you'll use a double. Then you have these two oddballs over here, okay? You have this guy called a Boolean, and he is the smallest data type we have. It stores exactly one binary number, so either a 1 or a 0, and a 1 or a 0 correlates to either an electrical signal traveling or not traveling down a circuit, okay? So Boolean has a bit of weird syntax at first. You have a Boolean, that's the type, then you give it a name, and you give it an assignment operator to assign a value, right? But Boolean only takes two values. Remember, Boolean stores either a 1 or a 0, right? And the way Java thinks of this is a true or a false, okay? So no capital letters in this, it's just lowercase true and lowercase false. So a lowercase true correlates with a 1 or an electrical signal traveling down a circuit, and a false correlates with a 0 or no signal traveling down a circuit, okay? This becomes pretty useful in control flow, which is in a later unit. And then we have the char. This is rarely ever used, right? But you are able to store one character, so one key basically on your keyboard, in this data type. And it's written in the ASCII format, and ASCII basically just means numbers that correspond to a key, right? So if you look up, look, right? If you look up ASCII table, you will see all of the letters and their corresponding values, right? This isn't really that important, but just know that you can store one character in this method. So to recap, integers, shorts, and longs all store whole numbers. Integers store reasonable numbers from 0 to about 4 million. So this would be storing the amount of money you make in a year. Shorts store pretty small values. So maybe the amount of money you make in a month. And longs store pretty massive values, right? So this would be the amount of money you make in 100 years, okay? And all of these data types here can only store whole numbers. So we use a float and a double for decimal points. A float has less precision than a double. That's the only difference. A float can have less decimal places than a double. A Boolean stores either a 1 or a 0. And this is signified by a false value or a true value. And again, this is really only useful for your conditionals, which come in a later unit. And then you have the char, which is used to store one character, and it's not really that widely used, but it's important to understand that all of your characters are going to be stored like this. They're going to be stored in the ASCII format, meaning that there's a number that correlates to each character on your keyboard. One small thing to add is that the larger a data type is, the more amount of memory or space in a computer it takes up. So a Boolean would take up the least amount of space. And then we're going to skip byte because it's rarely ever used. And then a short and a character take up the exact same amount of space, right? Which is 16 bits if you care to know that number. Then an int takes up the next bracket of space, right? So it's a pretty large amount. It's the exact same amount as a float, okay? And then longs and doubles both take up the exact same amount of space. So just remember, the larger a value is, the more space it takes up.